This time in the shot, let's build the GMRS J pole's big brother. Okay, the first thing we need to do is figure out the dimensions of our J-pole. So we'll go to a browser window, we'll search for J-pole calculator, and you can see it'll pull up a list of a bunch. This first one in the list is in the metric system, so we're going to ignore that. And we're going to come down here to the American version. I have nothing against the metric system, but my tape measures are all in inches, so very simple website to use. We'll put in the calling frequency of 146,520, and we'll calculate. And this shows that our dimensions are 58.85 inches for the long dimension, which is the half wave plus quarter wave. The half wave section is 38.69 inches. The quarter wave matching section is 19.35 inches. The feed point is 1.93 inches. Our spacing between the two elements is 1.75 inches according to the calculator. In reality, it's going to be less. In actuality, it's going to be about 0.7 inches. This will probably cause us to move our feed point up or down. We'll fine-tune it by doing that. But these are our critical dimensions. So the long length is 58.85. The quarter wave matching section is 19.35, and our feed point is roughly 1.93 inches. And that gives us a starting point, and we can trim from there. Okay, just as in the last J-pole video or J-antenna video that I did, that one was GMRS. This one is 2 meter, but they're both going to use the same piece of 200 PSI PVC pipe. So you can see this is just a hardware store item. And it's 200 PSI rated 3/4 inch PVC irrigation pipe is technically what it's used for. And because we're dealing with 2 meters instead of GMRS, of course GMRS is 460-ish megahertz, and 2 meter is 145, 146 megahertz. This antenna is going to be significantly longer, 3 times as long. And that matters because PVC isn't the best building choice for antennas to begin with, and it does tend to get a little bit flimsy the longer that it gets. So I kind of consider a 2 meter antenna to be the limit for this stuff. Anything lower in frequency and it's going to be diminishing returns. But for 2 meter, we're okay. Remember, the long leg is about 58 inches. So that's what we're dealing with. We have to have a 58-inch piece of pipe with a little bit of extra length if you want to clamp it to a mast on your roof. So I figure 58 inches plus a little bit of extra, we end up at about 6 feet. So 72 inches is what we're going to make this. And I've made a mark here at 72 inches, and I'm going to whack this off real quick. All right, now we have a 6-foot piece of 3/4 inch PVC pipe. Now I'm going to build this a little bit different. If you were going to build this to put it on your roof, what you would do is you would take a cap and you would just drill a hole in it the size of your coax, whatever that coax would be. So just drill a hole right in the bottom, run your coax up through, make your connections to the antenna, and away you go. I'm going to build this as a portable antenna. So the way that I'm going to do this is I'm going to take a coupler and I'm going to couple this to another section of 3/4 PVC. It's about the same length, maybe a little longer, just for a portable 2 meter antenna that you can lean up against a vehicle or strap to a tree or something along those lines, for a little bit better option than perhaps a mobile 2 meter antenna might provide. So in order for me to do that, I'm going to have to do things a little bit differently. What I'm going to do is I'm going to come up here where the bottom of the antenna is likely to start, and I'm going to drill a hole, and I'm going to run the coax through that hole. And the antenna, of course, will be up inside of this PVC pipe. So let me do that real quick. Okay, so that'll give me the ability to run my coax up in here. The antenna will start and off she goes. Now the dimensions that we got from the J-pole calculator on the internet are likely going to be too long. Very likely going to be too long. So 58.85 inches is what we got. And here's the secret ingredient to all of this, the simple house wire. So I choose to use this because it's much more available than twin lead. And also because if you want a twin lead antenna, just go to Ed Fong's website and get it there. I'll put a link to that below. Ed Fong's been doing the twin lead antennas for a long time. He's got them down. They're not overly expensive, and they work very well. But I choose to use house wire just because I usually have a lot of it laying around. And a simple 25-foot section of house wire can be bought at your local department store on the shelf, typically for less than 30 bucks. And you can make quite a few antennas. There's 3 conductors in here. So you can make quite a few antennas out of this stuff. So the first thing we'll have to do is we're going to have to cut off a piece of this that's long enough to cover everything that we're going to need. In this case, it's going to be 58.85 inches plus the spacing, which is going to be about 7/10 of an inch, plus the short leg, which is going to be about 19.35 inches. So let's call it 59 plus 20. We're going to need approximately 80 inches of wire. So I'm going to measure off 80 inches of wire. Okay, here's our 80 inches of wire. Now I'm going to do this a little differently. The last J antenna that I built, the GMRS J pole, I used insulated section of wire. On this one, I'm going to use the ground wire, which is non-insulated. And the only thing I'm going to have to do is make sure that the spacing is correct with some blue tape, masking tape, just like I did in the last video, just so that the wires don't touch and cause the matching section to go out of tune. And I'll show that in detail here in a few minutes. But the reason I'm doing that is because I have plans for the insulated wires for another antenna project upcoming. I'm going to do some mobile antenna experimentation with the insulated conductors. So the first step here is to go ahead and get this opened up so we can get what we need out of it. I'm just going to score this with a razor blade. Once I get it scored, I'll pull out the conductor that I need. In this case, it's ground wire. And there we have our nice shiny piece of 14 gauge house wire. Of course, this is the ground wire that you would typically put to the green screw inside of a box. Using non-insulated wire is going to change the velocity factor slightly, but since we know we're long to start with, and we know we're going to have to probably trim anyway, that will be okay. Okay, now what I'm going to do is I'm going to measure down 19.35 inches. And I'm going to put a bend. And my motion lights went off. Be right back. Okay. So 19.35 inches. This is our short leg. And I put a bend. And the reason we do that is because we need spacing. And the spacing on this PVC pipe just happens to be, on the inside, it just happens to be about 7/8 of an inch. So actually it's more than 7/10 of an inch. Outside, it's going to be 7/8 of an inch. Maybe just a little bit less. So let's go ahead and mark that out. So outside to outside needs to be about right like that, almost 7/8 of an inch. And we'll put another bend. And just like in the last video, I'm going to test this. And so that does work. Now we measure out the long leg. So the long leg is supposed to be 58.85 inches. Let's call it right about there. And this is the radiating element for our antenna. So short leg, 19.35 inches. Long leg, 58.85 inches. So I used the Slim Jim setting of the website, which is slightly longer than the Copper J, because the Copper J, using copper pipe, which is bigger in diameter, of course, would make the antenna a bit shorter. So now what I'm going to do is I'm going to go ahead, I'm going to put the blue tape on it now to make it rigid. And just make sure that you don't put the blue tape over where your feed line is going to attach. In this case, the feed line, remember, is going to be 1.93 inches from the bottom, right about there. So we'll stiffen this up with some blue tape. I'm going to acid test that real quick. And we'll put a few more. So the spacing needs to be maintained so that it can't change, because this is technically a transmission line or a stub. It's a transmission line. It's a transmission line that's been cut to a quarter wavelength, which makes it a quarter wavelength stub. And this is kind of the unique thing about J antennas, is how they're fed, or how they achieve a 50 ohm match to the coax and the transmitter. I'm going to leave this one down a little bit because we may have to trim the end of this matching section just slightly. And we'll test this whole assembly and make sure it slides in. Which it does. Now we attach our coax. Okay, soldering iron is warmed up. And of course I'm making it more difficult on myself. If this were just going to be a cap with a hole drilled in it, we could run the coax up through there and just a feed line, attach it, and then slide in the tube from the top and be done with it. But since I'm going to be doing it through a hole in the side of the tube, what I have to do is put this coax through the hole first. This is going to make this whole process a little bit more awkward, but it is what it is. So this is just a piece of RG8X, and it's solid, which isn't the best choice. Stranded would be better. Okay, time to solder. And the feed point is going to be, as I mentioned earlier, 1.93 inches up from the base. And when you do this, you want to do the center conductor to the long leg and ground shield, coax shield, to the short leg. Right about there. Trim off the excess. And now I get to shove it in the tube and we'll start doing some SWR testing. So I will go ahead and slide this in. And for now, I'm just getting it completely inside the tube, so there's nothing sticking out. And I'm also, which is going to add even more complexity to this tuning procedure, I'm also going to have to do a quick 5 or 6 turn air choke every time I do this. And that's just to get rid of common mode. After all, we want to check the SWR of the antenna, not the length of coax that it is attached to. So I've cut this coax about 15 feet long. Let me walk it out, get it up in free air, and let's see where we are. And survey says that at 142 megahertz, we are 1.2 to 1. So we are a little bit long. So let me go ahead and shove this up through. Now with the GMRS J antenna, we can only take maybe a 1/16 of an inch off at a time, or an 1/8 of an inch. This antenna is going to be 3 times less sensitive. So I'm going to go ahead and I'm just going to cut a 1/4 of an inch off. That did not move it very far, so I'm going to go ahead and cut a little bit more off. It's about 3/4 of an inch. That's 144. Let me cut just a little bit more. Okay, that's about 145 even. So what I'm going to do now is since I know I'm close, I'm going to go ahead and tighten this up a little bit. I'm going to change this to 150, and we'll change this to 140 megahertz. Because what we want is to be right in the neighborhood of 146 megahertz. We need that to be less than 1.5 to 1. And we're actually already there. So I'm going to walk this outside real quick and get it up in free air and check it again. I'll be right back. And it's not bad. It's about 140, let's see, it's about 1.0 something to 1. Okay, 1.12 to 1 at 145 megahertz. So I'm going to trim it just a little bit more. Take another 1/2 inch off. And back outside, and I'll get it up in free air again. And the SWR came down, but the frequency of resonance didn't really change, which tells me that I'm probably about time to shorten the matching section just a little bit. But I'm going to take another half or quarter of an inch, a quarter of an inch. And I'll go check it again. I think we may be good enough. So at 145.6 megahertz, we are 1.07 to 1. And when I go up to 147 megahertz, it's still less than 1.5 to 1. It's about 1.4 to 1. So the next step for me is I'm going to go ahead and I'm going to attach it to another piece of 3/4 inch PVC. And I'm going to lean this up against the garage wall outside and take another snapshot of the SWR and see where we are. And if it's good, then we'll be done. I'll have to do some final measuring and painting, but the hard part will be done. The tuning of the antenna will be done. And here's the final tally. So this is the entire 2-meter ham band from 144 megahertz all the way to 148 megahertz. And you can see it's below 1.5 to 1 everywhere. There's a 1.46 to 1. In the middle of the band, it's 1.079 to 1. All the way at the top of the band, it's just nudging over 1.5 to 1, but I'm not going to worry about that. The calling frequency, it's still good, 1.1 to 1. And all I've done here is I've put this on another section of PVC 3/4 inch, coupled it, and the antenna is just up above the garage roof. So one of the good things about J antennas is because it's a half wave over a quarter wave, the tip of the antenna is up in the air quite a bit. It's quite long. That's the entire antenna. So I'm happy with this project. I'm going to go ahead and take it apart and get the final measurements in case you want to build something like this. I'll give you the exact measurements that I ended up with, and then we'll put it back in and we'll paint it and finish up the build. So I will just bend this into a small hook. And I'll tie a piece of string around that. And I'll pull that just under the edge of that, so about an inch in. It's about an inch. And I'll pull that tight. Whoops, slid. Pull back down. We'll pull this tight. We'll stick the cap on. And we'll cut off the excess. And there we have it. A little paint and we'll be done. So the way we're going to test this is, I did a test with my 2-meter astroplane. Will give me full signal, full quieting at this frequency with this repeater output.
Yeah, but what talk group are they on?
And let's see what this particular J-pole antenna does in comparison. Basically, all we have to do is just wait for the repeater to ID itself, which may take a while. There you go. Full signal, full quieting. So this is a perfectly fine antenna. That repeater's about 40 miles from here as the crow flies. So there you have it. A cheap and easy J antenna build using house wire and cheap PVC pipe from the hardware store. And they work great. Thanks for watching.